All right, so today we're going to look at 1.4. And 1.4 is on linear functions. So we're talking about graphing functions in like y equals mx plus b format. When you're graphing a line in y equals mx plus b, the m and the b have a special meaning. The m is the slope, and the b is the y-intercept. What does that mean? Y-intercept, if you had to explain that a little bit more simplified, what does y-intercept mean? Yeah, Marcelo?
Where the line touches the y-axis.
Right, where the line touches the y-axis, where it crosses the y-axis. Yep. And we're talking about linear functions. So functions, remember, pass the vertical line test. We might touch on vertical lines. That's kind of a special case. Vertical lines are not functions. They fail the vertical line test. But most of the linear functions we draw are either going to be horizontal or they're going to have a slope that puts them on an angle. So they will pass the vertical line test. So a linear function is anything that can be written in the form y equals mx plus b. Okay, a couple conditions on m and the b. In our book, the m and the b have to be real numbers. So you can't have like a complex or an imaginary slope or intercept. And to be a linear function, the slope cannot equal 0. If the slope is 0, then our book calls that a constant function, right? That's a horizontal line. So like y equals 2. Right? If the slope is 0, that's just a horizontal line. That doesn't fit the definition of what our book calls a linear function. It's a constant function. Now, it says can be in that form. So if I gave you something like 2y plus 3x equals 6, is that a linear function? How about Raj? Is that a linear function?
Yeah.
Yes, it is a linear function because it can be written y equals mx plus b, even though it isn't. Right? How would I get that in y equals mx plus b? Anybody tell me? Yeah, Lance?
Subtracting 3x on both sides.
Okay, so we subtract 3x on both sides, and we want to put that negative 3x first because mx plus b, we're putting the number with x first. And then what would be your last step?
And then you divide by 2.
Then you divide by 2. Okay, so you can rewrite that so it's y equals mx plus b. Okay, so let's look at an example where we're going to be given some information and we're going to create an equation in y equals mx plus b. So this problem says that 10 years ago, a house was purchased for $60,000. And now the house is worth $85,000. So that's 10 years later. We're going to assume that there is a linear relationship between the value of the house and time. What that means is the value has gone up exactly the same amount every year over the past 10 years. Okay, maybe it's gone up like $1,000 or $2,000. But it's gone up the same amount. If we didn't know that the relationship was linear, we wouldn't be able to use y equals mx plus b. Okay, but they're telling us, let's assume that it is linear. I want to find an equation that represents this situation. And then I want to figure out exactly when the house was worth $71,250. All right. So when we write an equation in y equals mx plus b, what are the names of the two variables we need to fill in for? Lens?
Would it be the slope?
Yep.
The y-intercept.
And the y-intercept. So before we do this, we're going to leave a little bit of space so you can do the work for this. We got to talk a little bit about what the slope is. So that's the formula that we're going to need to use in this problem to find the slope. So you need two coordinates. Once you know your two coordinates, the slope is change in y over change in x. y2 minus y1 over x2 minus x1. Now we'll talk about horizontal and vertical lines. Those are special cases, but in this problem, we don't have to worry about it because our slope is not a special case. Okay, so let's go back up to our problem and see if we can figure out some coordinates. First thing is, what is the independent variable here? Let's see, yeah, Marcelo? Yeah, the time, right. So the year, how many years have gone by, the time, that's the independent. And what's the dependent variable? Yeah.
The price of the house.
The price of the house, the value of the house. Yep. So let's see if we can make a table with this information. So we've got, let's do how many years have gone by, and then the value of the house. What was the value of the house? We'll call it like the starting value of the house. Yeah.
60,000.
60,000. And how many years had gone by at the start? That's going to be, we'll call that like the finishing value. So that's our value now. 10 years have gone by. But how many years had gone by at the start? Yeah? 0 years. Okay, so at the very beginning, when we bought this house, right when we bought it, no years had gone by yet, and the value was 60,000. There's a coordinate we're going to use. And then can someone give me another coordinate using that information? Yeah.
10 years and then $85,000
Yeah.
value.
10 years, 85,000. Now this top coordinate, that one's kind of special. How come? What 0, 60,000? What? It's a coordinate, but that coordinate is telling me something about my line. Yep.
It's the y-intercept.
It's telling me the y-intercept. That's where it crosses the y-axis. So in this case, the b value is 60,000. So we've got b, 60,000, and now I need to find my slope. So to find my slope, what would go in the numerator to find my slope? Yes.
85,000 minus 60,000.
Yeah. y2 minus y1. So that's in the numerator. And what would go in the denominator? Ethan, what would go in the denominator?
10 minus 0.
10 minus 0. So what's 85,000 minus 60,000 is going to give me how much? 25,000, and then divide that by 10. 2,500. There's my slope. There's my y-intercept. Fill in those two numbers into y equals mx plus b, and that's the equation that we need. Okay, so slope is 2,500 times x plus 60,000. So we know the 60,000 in this problem represents the initial value of the house. What does the 2,500 mean in the context of the word problem? I mean, I know it's the slope, but what does the slope mean? Yeah.
How much it goes up every year.
Right, that's the change in the value of the house every year, $2,500. All right, so now let's use that equation to find the value of the house at $71,250. Where does the $71,250 get plugged in? For X or for Y? Yep, that gets plugged in for Y because that is a value, and we said value is the independent. So we're going to have 71,250 equals 2,500x plus 60,000. Okay, so let's solve for x and see what we get. So we've got 71,250 minus 60,000, and then divide that by 2,500. So after 4.5 years from when we bought the house, its value will be 71,250. So when was the house worth 71,250? So the house is worth after 4.5 years. Any question on how we came up with that equation and then used it to solve that problem? All right. So the slope we found there, that if you were to graph it, is a positive slope. There are a couple special cases. If you have a horizontal or a vertical line, horizontal line would have a slope of 0, and a vertical line would be undefined. And because the slopes are special cases, the equations are also special cases. Neither one of these is y equals mx plus b. Does anybody remember for a horizontal line what the equation looks like? It's simpler than y equals mx plus b. Yes, there.
It's just like y equals a number.
It's just y equals a number. Yep. So I'm just going to put that right here. Y equals a number. That is something we can graph on the calculator. Right? If you go to y equals, you can just put in y equals a number. There you go. Horizontal line. Does anybody remember what the equation of a vertical line looks like? Yeah?
X equals a number.
That is x equals a number. That I cannot graph on the calculator. The calculator is set up to graph functions. It's in function mode. When you have your calculator in function mode, it cannot graph a vertical line because a vertical line is not a function. You might get some things that kind of start to get very steep. Like if you had something like this. You might think, well, is that a vertical line right there? Because it's going straight up? No, or this one here, is that vertical? No, it's there's still a curve to it. It's steep, but it's not vertical. All right, so let's see if we can find the equation of, I already told you guys that down there, of the vertical line and the horizontal line that passes through the point 2, 3. let's start with the horizontal. What's the equation of the horizontal line that would go right through the coordinate 2, 3? Yep, Nick.
Y equals 3.
Yep, y equals 3. Not as complicated to find that equation as it was to do the house problem. Right, we have to do the slope and all that. You don't have to worry about as much here because these are special cases. And how about the equation of the vertical line that goes through the point 2, 3? T. Yep, x equals 2. And that's all they were looking for. Okay. Any questions on that? Kind of already touched on this. So remember, you might not always have something in y equals mx plus b. You may have to take it and rewrite it yourself. So if you were to rewrite that in y equals mx plus b, you'd subtract the 2x and then divide by 3. So subtract the 2x. That moves it to the other side, and then I'm going to divide by 3 at the same time. So when you simplify that, it would be y equals negative 2/3 x plus 2. Now, what's the advantage of taking this and writing it like that? You know, to write, they represent the same thing, but what's the advantage of this format over the one up above? That's
It's easier to graph.
Yeah.
Linear line.
makes it a lot easier to graph because now you know, okay, go up to 2 on the y. If this was your grid. Right? You're going up 2 on the y. There's your y-intercept. And then your slope is down, is rise over run. Down 2, right 3. Down 2, right 3. And then draw your line. Okay, so knowing the slope and intercept just makes it faster a lot of times to do the graph. That's the advantage. Now, even though we use y equals mx plus b a lot, it is not the only way to write the equation of a line. Another format is point slope. A lot of times I use this as kind of a middle step. Right? If you tell me that you need an equation of a line that goes through the point 5, 7, and it has a slope of 3, I'll use this to figure it out. What variable is not in this equation that we saw in the other equation for a line? Yeah.
There's no B.
There's no b. You do not need the y-intercept when you're writing an equation in this format. You need the slope and you need a point. So let's try writing an equation in this format and then converting it back to the format that we just discussed. So it says find the equation of the line with a slope of a half, and it has to pass through the point negative 2, 3. Okay, so first, there are 3 things we need to plug in. I just want to make sure we know which one is which. Where is the 1/2 going to get plugged in? That'll get which letter? Marcel?
M.
That's going to be your M. How about the negative 2? What are we going to plug that in for? Yeah.
X1.
That's your x1. And the 3 would be your y1. Okay. So let's fill in those 3 three things and see what we get. I don't have a ton of space usually on the smartboard. I can make more space, but I'm just I'll start it up here. So y minus y1 equals m times x minus x1. Okay, so be careful there because it's x minus 2. What's going to happen right there with that minus and minus? Yeah, that's going to become a plus, so let's take care of that. And that is your answer in point slope form. Now, let's say they asked us to convert that when we were done to y equals mx plus b. What would be your first step to getting that into slope intercept? Yep. Yep. So distribute the 1/2. Now it's kind of in between the two. That format we've got right there, that's nothing. It's in between the two. And then what would be my last step? Yep.
Add 3 to both of those.
Just add, yep, add 3. So there's your answer in slope intercept. And this one right here, that is point slope. Any question on how we got the point slope or how we converted it to slope intercept? Now, there is a third way, and that's called the general form. We use something that looks kind of like this more when we do quadratics. We get them equal to 0. We don't do it as much with lines. But if you put everything on one side and get it equal to 0, that is called the general form. So like if I took that y equals 1/2 x plus 4, there's lots of ways you could write that in general form. Okay? You just have to get 0 on one side. So you could do this. And then we usually put it x, y, and then the constant. So x, y, and then the constant. That is general form. Now, let's say, for whatever reason, they said write it in general form, but they also said to not leave any fractions in the final answer. What could we do to all 4 terms so there's no fractions anywhere? Marcel?
Multiply by 2.
Yeah, could multiply everything by 2. 0 equals x minus 2y plus 8. And the reason I show you that is because when you are writing something in general form, if it was a multiple choice question, you could see different formats. There's lots of ways you can do it. Our book usually does it without fractions. So you may have to multiply through by a constant. Any question how I changed that last equation into general form, or how I cleared the fractions? All right, so parallel and perpendicular lines. How would you describe if 2 lines are parallel? What would have to happen? There's actually a couple things. Yep.
They'd have the same slope.
Okay, same slope. And one other thing. Yep. And never touch. Okay. What else could we say if they have the same slope and they never touch? That is correct. What would be something kind of related to one of the equations we talked about today that we could say? Same slope. Yeah.
Different ways.
Different y-intercepts. Yeah. That would make it so they never touch. How about perpendicular? Does anybody remember what the connection is between two lines that are perpendicular? Nick?
They have opposite reciprocals.
Opposite reciprocal slopes. Yep. So remember, opposite means positive, negative. Reciprocal means to flip it. So if you had a line with a slope of 2/3, what would be the line that is, what would be the line's slope if it's perpendicular to one with 2/3? Yeah. -3/2. Yep. Now, let me graph two lines, one with a slope of 2/3 and one with a slope of -3/2. Now, if they are perpendicular, what angle do they cross at? Yep, sorry.
90 degrees.
90-degree angle. Yep. Let's draw these and see if they cross, if it looks like they cross at a 90-degree angle. So I'm just going to draw two lines right through the origin, 2/3 x and -3/2x. And I'll do zoom 6. Okay. Does it look like those lines cross at 90-degree angles? No, they don't look like 90s, right? And if you look at like this angle right here, it's definitely smaller. And the reason it's smaller is because the screen is not a square shape. Right? The screen is a rectangular shape. Look at how many units you're putting horizontally. That's -10 to 10. That's 20 units horizontally, and -10 to 10 on the y. That's 20 units vertically. So you're putting the same amount of units in a horizontal direction and a vertical direction, but the horizontal direction is a bigger length on the screen. So you're never going to see things the way they really should be if you do like a zoom 6. If you really want to see things proportional, you have to do what's called zoom square. If you do zoom square, which was zoom 5, it will make things look proportional and they're not distorted. Okay. Now, if you were to actually measure that, that is a 90-degree angle. Okay. And if you look at the window, notice on the height, we have 20 units. On the width, we have about 32 units and a little left over. That's about the ratio you need if you want to make things look proportional. If you take the value you set for your y and you multiply it by about 1.6, that will give you a proportional looking screen. So in other words, the width of the screen, or the left to right length of the screen, is 1.6 times as much as the up and down of the screen. And that's built into the calculator if you do zoom 5. But if I wanted to do my own, like let's say I wanted my y's to be 30 and -30, I should be able to multiply those each by 1.6. And you can actually type it in like that. Times 1.6. And the other one will be the same, 48. Let's hit graph. Let's see if they look like 90-degree angles. Or close. It wasn't exactly 1.6, but it should look pretty close. No, that looks pretty good. All right. Any questions on that? So it's kind of a calculator thing. All right. So let's write an equation of a line that is parallel to this one and passes through the point 1, -2. What's the first thing that I should do if I want to figure out something that's parallel to that?
Did
Lens?
you put it in in slope intercept form?
Yeah, I would rewrite that in slope-intercept form. So we would have negative 2y, let's see, equals, we're going to subtract the 3x to the other side. So negative 2y equals negative 3x plus 1. And what would be my last step to get y by itself there? Yeah, Marcelo?
Divide by 2.
We divide by what?
-2.
Negative 2. So that's going to give me y equals 3 over 2x plus, or actually it's going to be minus a half. Sorry, that comment box keeps popping up. So y equals 3 over 2x minus a half. Okay, so now I've rewritten that one in y equals mx plus b. What's the next thing that I would do if I'm trying to find a line parallel to that? What do I know about my line now? Vanessa? And that slope is going to be how much? And that slope is going to be how much? 3 over 2. Yeah. So we know it has the exact same slope as the line that we're working with because it's parallel. So our slope is 3 over 2. And I have a point it has to pass through. 1, negative 2. We just fill that information into point slope, and we're all set. So our final answer is going to be, put it right here, y minus y1. y1 is negative 2, so it's y minus minus 2 equals m, which we know is 3 over 2, times x minus x1. There is an equation that is parallel to the one they gave me and will pass through the point 1, negative 2. They didn't say how to write the final answer, so I did point slope because that was the easiest based on what I had. Any question on that? So you could see a problem that says find one parallel, find one perpendicular, and then write your answer in a certain format. All right, so the last thing is linear inequalities. So when we're graphing linear inequalities, that's where we graph a boundary line, and then we shade on one side of it. There's two options for the boundary line. You either do a solid line or a dotted. If you have one of these two inequality symbols, you need to make the boundary line solid. If you have one of these two, you can make it a dashed boundary line or dotted. So that's the rule for determining whether it should be a solid line or a dotted line. How you graph the line, well, that's up to you. Okay, that's something you learn in Algebra 1, so if you want to use the slope and the y-intercept, rise over run, however you want to graph your line is fine. Now, once you graph your line, and then you make it either solid or dotted, you have to determine what side to shade on. Okay. The easy way to figure out what side to shade on, I'm just going to make a chart here. If you have a less than or equal to, or a less than, shade below. if you have the greater than symbols, shade above. So I'll write it like that. Now, the only case where that doesn't really work is a vertical line. If you draw a vertical line, there is no above and below. So if you had a vertical line and I had a less than symbol, which side of the vertical line do you think you would shade on? Which side? Yeah, the left. And if you had a vertical line and it said greater than symbol, you would shade to the right. But for anything that's not vertical, there will always be an above and a below. Okay, so now you know what kind of line, you know what side to shade on. Let's try an example. So it says to graph 2x plus 3y is less than 4. Okay. What would be my first step? Yeah, go ahead, Jackson.
Subtract 2x from each side.
Okay, so if we subtract 2x from both sides, we get 3y is less than negative 2x plus 4. All right, can you keep going with that?
Then divide each side by 3.
Okay, and what would that give me?
Y equals negative 2
Did you
thirds.
say that one more time?
Y is less than negative 2 thirds x plus 4 thirds.
Perfect. Okay, so we've rewritten that. Now, something that could come up but didn't come up is we divided each side by positive 3. What do you have to be careful about when you are doing division with inequalities? Yeah.
The signs can flip.
When would the sign flip?
Divide to the negative.
Dividing by a negative. Yep. If you divide or multiply both sides of an inequality by a negative, you need to flip the sign. Okay. So now we've got our line that we need to draw in y. It's like y equals mx plus b, but it's y is less than. Okay. Now, how do I graph that? What's the first thing I would do? Yep, Vanessa? We're going to put a point on the y-intercept. 4 thirds, that's 1 1/3. So we'll just kind of estimate about right there. Okay, so we've plotted the y-intercept. All right, now what do we do next? Yep.
We can plot a point for x equals 1.
Okay, you could plug in 1 and do the math out and then see what y is. What would be even easier where we don't have any math to do out? Yes. Yeah, just use the rise over run. And the slope in this case is negative 2 thirds. So from this point, how would I get to another point using my slope? Just need to know the directions to go. Yeah?
You would subtract 2 thirds from from your current value on the y-axis and then add 1 to the value of x.
So what's your rise in this case?
Negative 2 thirds x. Well, to negative 2 thirds.
That's my slope. What's just my rise? Rise and run are always integers if you've written a proper rational number for your slope, which we have. Lens? What is it?
The
rise is -2. And what about my run? Three. So now, knowing my rise is -2 and my run is 3, what does that tell me to do from this point to get to another point? Vanessa?
Go down.
Go down 2 and what?
Over 3.
3 to the right. So down 2, right 3. So we're going to go down 2, 1, 2, and then 1, 2, 3 to the right, right there. And we can do it as many times as we want. Go down 2, 3 to the right, down 2, 3 to the right. You can also go the other way. You can reverse it. Instead of down 2 and right, you can go up 2 and left. So you can go up 2 and left. The only reason I'm doing it so many times is because I don't have access to a smart notebook where I can easily draw the line. So that gives me a lot of points to do it by hand. And should this line be solid or dotted? What kind of line should this be? Yeah,
It should be dotted.
this should be dotted. So I'm going to make it dotted. And one more thing I need to do to graph this inequality, and that is to do what?
Shade
Yep.
below.
And Evan, right? Yeah. Evan, we're going to shade below. Yep, because it's a less than symbol. And I usually just do something like this. And remember, that shading represents the solution set. So you could pick any point that's in the shaded area, and you could plug it into the original problem, and it would work. So you could plug in a point, like a really simple one to plug in, 0, 0. That's definitely in the shaded area, and check it. If you plug in a 0 there and a 0 there, you get 2 times 0 plus 3 times 0. 0 plus 0 is less than 4. Yep, 0 is less than 4. So that's how you can check that you shaded properly. Pick a point like 2, 2. If you plug in 2, 2, that's not going to work. 4 plus 6 is less than 4? No. That's because that's up here. It's not in the shaded area. Okay, so that's graphing inequalities. Any questions on that? Yes?
Wouldn't the running be -3? Because -2 and 3?
So the rise is -2. So the negative, so there's your rise, and there's your run, right there. So you put the negative. I usually do it with the top number. So if if it's negative, I go down and to the right. If it's positive, I go up and to the right. That's how I always do it. The only reason I go to the left is if I'm on the edge of my paper and I can't go to the right. Then I can reverse it and go the other way. Okay, so you already did page 31. That was last night. So tonight's homework is page 42. Okay, so we'll take a look at that tomorrow. The plan then after that is to do section 1.5, and then Friday 1.6, and that will finish chapter 1.